Hello students, myself Shrisha Vivi. I am working this Shaka Vidyanaketana PU College as NEET as well as JEE coaching faculty. First of all, I would like to welcome one and all for this online JEE NEET Foundation classes. In this foundation class, we are going to discuss important concepts of first PU physics syllabus, and also we will solve important problems, few problems in JEE as well as NEET level. So physics is a very interesting subject. If you understand the concepts clearly, then only you can solve more and more number of problems. So it is very important to understand each and every concept in physics. So first chapter, mechanical properties of solids. So we know that matter exists in our nature in three states. They are nothing but solid, liquid as well as gases. So in case of gas possesses definite shape, while liquid and gases do not possess definite shape. Usually liquid will take the shape of the container. Volume. So here solid as well as liquid possesses definite volume, while gases do not possess definite volume. So intermolecular force. So in case of solids, the intermolecular force is strongest. So that means the force between the molecules is strongest, and hence the molecules are closely spaced. While in case of liquid, so the intermolecular force is less when compared to the solids, but it is more when compared to the gases. While in case of gases, the intermolecular force of attraction is weak. So freedom of motion. So freedom of motion for molecules in case of solids is less, and it is more in case of liquids, and it is maximum in case of gases, and hence the gas molecules can move freely and take volume. Next, types of solids. In solids there are two types. One is crystalline and another one is amorphous. Crystalline, in case of crystalline solids, there is an ordered regular three-dimensional arrangement of atoms, for example diamond. And in case of amorphous solid, there is no regular ordered arrangement of atoms, example glass. Next, another important property possessed by solids, that is elasticity. So in case of, if you consider a spring, when you stretch the springs by applying some force, its length is going to increase. When you compress the spring by applying force, then its length decreases. That means the spring will regain its original shape. Similarly, in case of rubber also, if you stretch the rubber, its length increases, while if you compress the rubber, its length decreases. This property is nothing but elasticity. So it is the property of material by the virtue of which it regains its original shape and size. That is called as elasticity. Elasticity means it is the property of a material by the virtue of which it regains its original shape and size. Elastic bodies. So example rubber, plastic bodies. Plasticity means the material if the material do not regain their original shape and size even after removing the forces, then that property is known as plasticity, and those materials are called as plastic bodies. Example wax. Okay students, deforming forces. The forces which tends to change the shape of the body are called as deforming forces. So when the deforming forces are applied, there will be a change in shape and size of the body, and when the deforming forces are removed, the body will regain its original shape and size. That property is nothing but elasticity, and the materials which are exhibiting this property are called as elastic bodies. So if the deforming forces are continuously acting on a body, then after a certain limit, the body may not regain its original shape and size. That limit is called as elastic limit. So after that, the body will not regain its original shape and size. Next, stress. So stress means the internal restoring forces acting per unit area is called as stress. So here the mathematical form of stress is given by S is equal to F by A. So we know that unit of force is Newton, SI unit of area is meter square, therefore unit of stress is Newton per meter square. So whenever the deforming forces are acting on a body, inside the body the restoring forces are developed, and that internal restoring forces acting per unit area is called as stress. So different types of stress. So first one is normal stress. So in case of normal stress, the deforming forces are acting normal to the surface. So longitudinal stress. So in this case, the deforming forces are acting parallel to the length of the body, which results in increasing length of the body. That is called as longitudinal stress. In case of volume stress, the internal restoring forces are developed all over the body, which tends to increasing volume. The stress developed in this case is called as volume stress. So in case of normal stress, the internal restoring forces are developed. So here the deforming forces are acting normal to the surface. In case of longitudinal stress, the deforming forces are acting parallel to the length, while in case of volume stress, the internal the deforming forces are acting throughout the body. So shear stress in this case, so the deforming forces are acting tangential to the surface. So next, strain. So strain is another physical quantity. Here the strain can be defined as the ratio of changing configuration to the original configuration, or you can also define it as the change in dimension to the original dimension. So it has no units. So different types of strain. Corresponding to the three types of stress, there are three types of strain. First one is longitudinal strain. The ratio of change in length to the original length is called as longitudinal strain, and that is given by delta L by L, where delta L is nothing but small change in length, while L is the original length. Volume strain is defined as the ratio of change in volume to the original volume, and that is given by delta V by V, where delta V is the small change in volume, where V is the original volume. Next, third one is shear strain, the ratio of relative displacement of the adjacent layers to the original length, that is called as shear strain. Okay students, a famous scientist named Robert Hooke deduced a law which gives the relationship between stress and strain. So that is called as Hooke's law. So within the elastic limit, stress is directly proportional to strain. That is the statement of Hooke's law. Hooke's law states that within the elastic limit, the stress is directly proportional to strain, or the ratio of stress to strain is always a constant for a given body, and that constant is given by E, where E is called as modulus of elasticity. So there are three different types of modulus of elasticity. First one is Young's modulus of elasticity. It is defined as the ratio of longitudinal stress to the longitudinal strain. So you know the formula for longitudinal stress, that is given by F by A, where longitudinal strain is given by delta L by L. Therefore Young's modulus Y is equal to F by A divided by delta L by L. So then the formula can be written as Y is equal to F by A into L by delta L. So if a force F acts on a wire of radius R by hanging a weight M, then it can be written as F can be written as M into G into L divided by A. A means area, that can be written as pi r square, where R is the radius, into delta L. So if a force F acts on a wire of radius R by hanging a weight of mass M, then Young's modulus formula can be written as mgL divided by pi r square into delta L. M mass, G acceleration due to gravity, L original length, pi into r square, where r is the radius of the wire, delta L is the change in length. So by using this formula, the change in length can be calculated by using the formula delta L is equal to F into L divided by A into Y, or it can be written as mg into L divided by pi r square into Y. Okay, students, now we will discuss a few MCQs type questions related to Young's modulus formula as well as stress formula. So the problem is there is a steel rod has a radius of 9.5 millimeter and length 81 centimeter. So when a force of 6.2 into 10 power 4 Newton stretches it along its length, then what is the stress developed in the rod? So before solving the problem, first write the given values. So data. So length is given. Vertical length of the rod is given, that is 81 centimeter. So here radius is given, R is equal to 9.5 millimeter, and here a force F is equal to 6.2 into 10 power 4 Newton. So these are the given values, given data. So you know the formula for stress. Stress is given by S is equal to F by A. So force is given, here radius is given. So then the formula can be written as F divided by A can be written as pi r square area. Now substitute the values. F value is 6.2 into 10 power 4 divided by pi value 3.14 multiplied by r. Radius is given by how much? 9.5 millimeter. It is given in millimeter. You should convert it into meter. 9.5 into 10 power minus 3 whole square. Now simplify. You will get the final answer. That is 6.2 into 10 power 4 divided by, here it is 3.14 multiplied by 9.5 square. 9.5 square into 10 power minus 3 square, it becomes 10 power minus 6. So now it can be simplified as follows: 6.2 into 10 power 4 divided by 3.14 multiplied by 9.5 square. So when we add the 10 power minus 6 to the numerator, it becomes 10 power plus 6. 10 power plus 6, 10 power 4. It becomes 10 power 10. So in order to simplify this, so in JEE as well as NEET exams, there is no option to use calculators, and hence, so take this value as 6 only and this one as 3.14, 3 only. Therefore, it can be simplified as 2 into 10 power 10. So instead of taking 9.5, so better you take this as 10 only. So 10 square it becomes 100. So 100 means 10 power 2. So approximately you will get 2 point something into 10 power 8. 2 point something into 10 power 8 Newton per meter square. This is the stress developed in the rod. So here I will take the approximate values since options are given. So the nearest answer is around 2 point something. Actual answer is 2.2 into 10 power 8 Newton per meter square. So you will get the nearest answer since the options are giving. There is no problem. Students, next problem. One end of a thin horizontal copper wire. One end of a thick horizontal copper wire of length 2L and radius 2R is joined welded to N and end of another thin horizontal copper wire of length L and radius R. So when the alignment is stretched by applying the force at the two ends, then calculate the ratio of elongation produced in thin wire to that of thick wire. So here there are two wires. One is copper wire of length 2L. Copper wire is of length 2L having the radius 2R. This wire is welded with another wire of length L having the radius R. Now this arrangement is stretched by applying the force at the two ends. Then calculate the ratio of elongation produced in the thin wire to that of the thick wire. Both the wires are of the same material, copper, and hence the Young's modulus is same for both the material, for both the wires. Same force is applied at the two ends. Force is also same. So you know the formula for Young's modulus. Young's modulus is given by y is equal to f by a divided by delta L by L, where f is the applied force, a is the area, delta L is the change in length, and L is the original length. So now this can be written as delta L is equal to f by a into y into L. So now for thin wire you can write delta L as delta L1 is equal to f into L1 divided by A1 into y. Similarly for thick wire you can write elongation, that is delta L2 is equal to f into L2 divided by A2 into y. So in the problem you are asked to calculate the ratio of elongation produced in the thin wire to that of thick wire, ratio of delta L1 to delta L2. So now divide these two equations, divide equation 1 from 2. Divide equation 1 from 2. This implies delta L1 divided by delta L2 is equal to delta L1 is f into L1 divided by a into y, a1 into y multiplied by delta L2 that can be written as a2 into y divided by f into L2. So f is same force is applied, Young's modulus is also same. Then the ratio delta L1 divided by delta L2 is equal to L1 by L2 into A2 divided by A1, where L1 is the original length of the thin wire, that is L divided by L2. L2 is the original length of the thick wire, that is 2L, multiplied by here A2, area of the thick wire. Area can be written as A is equal to pi r square, where r is the radius. Now A2 can be written as pi into r2 square divided by pi into r1 square. Pi gets cancelled, L gets cancelled. Then you can write 1 by 2 into r2 represents the radius of the thick wire. Radius of the thick wire is 2r, that is 2r whole square divided by radius. R1 represents the radius of the thin wire, that is r only r square. That can be written as 1 by 2 into 4r square divided by r square gets cancelled, that is equal to 2. So the ratio of delta L1 to delta L2 is equal to 2. This is the answer. Actually this problem is asked in last year, before last year JEE Mains examination only. So here I will repeat once again. So there are two wires, both are made up from same material. One wire is having the length 2L, having the radius 2R, while another wire is having the length L and the radius R. These two wires are joined, then force is applied at the two ends. You are asked to calculate the ratio of elongation. So by using the formula of Young's modulus, y is equal to f divided by a divided by delta L by L. So then write the elongation produced in the thin wire as well as thick wire. Elongation produced in the thin wire is delta L1 is equal to f L1 divided by A1 into y. For thick wire, delta L2 is equal to f into L2 divided by A2 into y. Divide equation 1 from 2, then you will get this equation. Here I cancelled f since same force is applied at the two ends, as well as y also since both the wire is from same material. Then you will get L1 by L2 into A2 by A1, where A is the area, formula is pi r square. Then L1 by L2 gives 1 by 2 into R2 by R2 square divided by R1 square, that is 2R whole square divided by R square. Simplify, then you will get the ratio of elongation in thin wire to that of thick wire is 2. Students, next problem. A wire is stretched by 0.01 meter by a certain force F. There is another wire of same material but its radius as well as length are double to the original wire, is stretched by the same force. Calculate the elongation produced in the second wire. So in the first wire, elongation produced is L1. Elongation produced is given by 0.01 meter. Calculate the, or you can take the elongation as delta L1 or simply L1 only. Calculate the elongation produced in the second wire, that is delta L2 is equal to how much? So here let the original length of the first wire as L, length of the second wire as 2L, and similarly radius of the first wire as R and the radius of the second wire as 2R. Both the wire are made up of the same material, that means Young's modulus is same. Young's modulus is same, and also same force is applied. F is also same. So calculate the value of delta L2. Use the same formula, Young's modulus formula, that is Y is equal to F by A divided by delta L divided by L. L goes to the numerator. That is the original length. So that is delta L is equal to F into L divided by A into Y. So for the first wire you can write delta L1 is equal to F into L1 divided by A into Y. A into Y or A1 into Y. Similarly for the second wire, delta L2 is equal to F into L2 divided by A2 into Y. So you are asked to calculate the value of delta L2. Delta L1 value is given. So divide equation 1 from 2. Dividing equation 1 from 2, you can write delta L1 by delta L2. Delta L1 by delta L2 is equal to F into L1 divided by A1 into Y. Here A1 can be written as pi R1 square into Y multiplied by, this becomes pi R2 square into Y divided by F into L2. So here also F and F, Y and Y gets cancelled, pi gets cancelled. Then the ratio delta L1 by delta L2 is equal to L1 by L2 into R2 square divided by R1 square. Now substitute the values. L1 is L, L2 is 2L, L1 is L, L2 is 2L, R1 is R, R2 is 2R, R2 value is 2R, 2R whole square divided by R1 is R only, R square. Then you will get delta L1 by delta L2 is equal to, L1 gets cancelled, 1 by 2 into 4R square divided by R square, R square, R square gets cancelled, then you will get 4, 2 2s are 2. Therefore, you are asked to calculate the value of delta L2. Delta L1 by delta L2 is equal to 2. Delta L2 is equal to delta L1 divided by 2. Delta L1 value is given, how much? 0.01. 0.01 divided by 2. That is equal to how much? 0.005 meter is the elongation produced in the second wire. Simply by using Young's modulus formula, first write the formula for elongation produced in the first wire and then elongation produced in the second wire. Divide the two equations, substitute the values of L1, L2 as well as R1, R2, simplify, then you can calculate the elongation produced in the second wire, that is 0.005 meter. Okay students, next problem. How much force is required to produce an increase of length? How much? 0.2% in length of a brass wire having the diameter 0.6 millimeter. So what is the minimum force required to produce an increase in length of 0.2% to its original length? So given diameter is equal to 0.6 millimeter. So convert it into meter, that is 0.6 into 10 power minus 3 meter. Young's modulus is given 0.9 into 10 power 11 Newton per meter square. So use the Young's modulus formula, that is Y is equal to F by A divided by L by L or delta L by L. that can be written as F by A into delta L in the numerator L. So you are asked to calculate the value of F here. Now rearrange the equation. F is equal to y into A into delta L divided by L. F is equal to y into A into delta L divided by L. Now substitute the values. F is equal to y means 0.9 into 10 power 11. Area, formula for area is pi r square. So here diameter value is given. So therefore you can calculate the radius. R radius is equal to d by 2. Therefore it becomes 0.3 into 10 power minus 3 meter. So area that can be written as pi r square into delta L divided by L. I will write here. F is equal to Young's modulus value is 0.9 into 10 power 11 multiplied by pi value 3.14 multiplied by radius 0.3 into 10 power minus 3 whole square multiplied by delta L by L, that is the ratio of change in length to the original L. That value is given 0.2%. I can write it as 0.2 divided by 100. So simplify these values, then you get F is equal to 51 Newton. This is the force required to produce an increase in length of 0.2%. So in the given problem, Young's modulus value is given, diameter is given, therefore you can calculate the radius. You are asked to calculate the value of F here. Write the formula for Young's modulus. Rearrange the terms, then you get F is equal to y into A into delta L by L. Therefore, after substituting the values, then you get F is equal to 51 Newton. Students, take this problem as homework. So a wire of cross section 4 mm square is stretched by 0.1 mm by a certain weight by applying some force. How far its length will be increased if the wire is made up from same material but of area 8 mm square stretches under the action of same force. So there is another wire but having the area of 8 mm square. It is also made up from the same material. It is also acted upon by the same force. Then what will be the elongation produced in the wire? Use the Young's modulus formula and try to calculate the elongation produced in the second wire whose area of cross section is 8 mm square. In the first wire, which is having the area of cross section 4 mm square, extension produced is 0.1 mm. Calculate the elongation produced in the second wire whose area of cross section is 8 mm square.